An introduction to complex number. The square of any real number is always positive. So, square root of negative number is not defined because not real number to satisfy the equation. Let's say we have the simple quadratic function x squared plus 1 equal to 0. So to determine whether the equation have real root or not, a determinant b squared minus 4ac was applied. For this simple question, x squared plus 1 equal to 0, the b squared minus 4ac is less than 0. So the equation has not real roots. Complex number a plus bi was introduced to solve such polynomial equation which has not real roots. Let us discuss the simple quadratic equation x squared plus 1 equal to 0. First step, we do transpose the positive 1 to right hand side become negative. So we have x squared equal to negative 1. Then we square root both sides. We obtain x equal to plus minus square root negative 1. Square root negative 1 does not exist in real number r. So we denote square root negative 1 equal to I. So our solution for x squared plus 1 equal to 0 is negative I and positive I. Any number of the form a plus bi, where a and b are real number and the I is the imaginary unit, is called a complex number. Let's say we have the complex number z equal to a plus bi. If b equal to 0, then z equal to a, which is a real number. If a equal to 0, then z equal to bi, which is an imaginary number. If a and b not equal to 0, then z is called the zero complex number. Thus, z equal to a plus bi. Example, z equal to 3 minus 4i. So the real part equal to 3, the imaginary part equal to negative 4. Now we are going to perform elementary operation on two complex numbers and express it in Cartesian form. Addition and subtraction. We just do as the operation of polynomial, adding the like term. To add and subtract two complex numbers, we just do the plus minus the real part and form the real part, and plus minus the imaginary part and form the imaginary part. Addition and subtraction are commutative, where z plus minus w equal to w plus minus z. Multiplication. To multiply two complex numbers, we just use the combined like term method. Don't forget, when we obtain I squared means we have the square root negative 1 squared. We get negative 1. And I to the power 3 equal to negative I. And I to the power 4 equal to 1. Multiplication is associative, where z multiplied with w conjugate equal to z conjugate multiplied with w conjugate. Division. To divide two complex numbers, we just multiply denominator and numerator by the complex conjugate and do expands and simplify for the solution, and finally we have the answer in the standard form. Question and solution of elementary operation on complex number. Question 1. If complex number z equal to 4 plus 5i expressed in the form a plus ib, the complex number part A, complex number z minus 4i multiplied with complex number z minus 6i, and part B, complex number z plus 1 divided by complex number z minus 4. Question A. Complex number z minus 4i multiplied with complex number z minus 6i. As we know, given that complex number z equal to 4 plus 5i, so z minus 4i equal to 4 plus 5i minus 4i. So we have 4 plus I. And the second expression, z minus 6i equal to 4 plus 5i minus 6i. So we have 4 minus I. The next working solution, we continue with do the multiplication of two new complex number. That is 4 plus I multiplied with 4 minus I. So finally we have 16 minus 4i plus 4i minus I squared. I squared means square root negative 1 bracket square. So we have negative 1. So 16 minus bracket negative 1, we have 17. Question B sounds like this. Complex number z plus 1 over complex number z minus 4. Given complex number z equal to 4 plus 5i. So convert the complex number z equal to 4 plus 5i in numerator and denominator. So we obtain 5 plus 5i over 5i. The complex number at the denominator is 5i. So the complex conjugate is negative 5i. So multiply the numerator and denominator with negative 5i, we obtain negative 25i plus 25 over 25. Do the simplify, we obtain the final answer is 1 minus I. Equality of complex number. Complex number have a similar definition of equality to real number. Two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. Let's say complex number a1 plus b1i equal to a2 plus b2i. So the real part a1 equal to a2. The imaginary part b1 equal to b2. Use the conditions for the equality of two complex numbers to solve the problem. Find the complex number z in the form a plus ib that satisfy the equation z squared equal to negative 3 plus 4i. Given that z equal to a plus ib, and we request to solve the equation z squared equal to negative 3 plus 4i. So we convert the z equal to a plus ib. A plus ib bracket square equal to negative 3 plus 4i. So we do the multiplication for a plus ib, multiply with a plus ib, we get a square negative a square minus b square plus 2abi equal to negative 3 plus 4i. So we use the condition of equality to solve. So the real part equal to real part. The real part a square minus b square equal to negative 3, and the imaginary part ab equal to 4. From the second equality, obtain ab equal to 2. So b equal to 2 over a. Substitute the b equal to 2 over a into the equation 1. So we have a square minus bracket 2 over a square equal to negative 3. Then you do the expansion, we got a to the power 4 plus 3, a to the power 2 minus 4 equal to 2, 0. So we do factorization, we have a square minus 1 multiply with a square plus 4 equal to 0. Since a square plus 4 greater than 0 for the real number of a, therefore a square equal to 1. So a equal to plus minus 1. When a equal to 1, we have b equal to 2. When a equal to negative 1, b equal to negative 2. So the final answer, the z complex number z equal to 1 plus 2i or negative 1 minus 2i.